Hello, everyone. Welcome to our session. Today, Jeffrey and I will present the challenges and opportunities UC Tech to support digital humanities or humanistic research in general. So Jeffrey and I are from UC Santa Cruz. Jeffrey is the research IT lead, and I, like digital humanities, stand in this intersection between humanities and tech. So in the past year, we had a few projects we want to work on, and we have this experience on digital humanities. So today I would like to discuss this UC Tech for digital humanities. Okay. So first of all, I would like to discuss the definition of digital humanities because it is kind of strange term even to humanities scholars. So digital humanities is the scholar activity of this intersection between humanities and technology. As you know that this IT technology develops so fast every day that it is accessible to even people who don't use technology very often. So there is such a booming field in humanities now that encourage scholars to integrate technology in their research, teaching, and learning. So it is a kind of new mode of scholarship. And I would like to present you this chart. And you see that from 2005 to 2014, these 10 years, the digital humanities papers grows exponentially. So you can see from this chart, there's stronger and stronger interest in integrating technology in research. But on the other hand, it is a broad term because humanities itself include many disciplines, and there are even a broader range for technologies. So what technology you use really depends on your research topics and the human resources you have. So it is a broad term that includes arts, history, literature. These three are the three major fields now in digital humanities. The next one is, so digital humanities, although it is humanities, but actually it attracts a lot of people outside of humanities to pursue it, because now, you know, research is quite interdisciplinary. So many students and researchers in social science and STEM fields, they are very interested in digital humanities too. And UCLA has a digital humanities minor, and this is their students make up every year. And you see from these charts that social science and STEM students are actually the major students of this digital humanities minor degree program. Although this is also because of the smaller total number of humanities students, but you see this strong interest of STEM students and social sciences in digital humanities. So for digital humanities, it is such a booming field in humanities because it brings a lot of opportunities. So first of all, it is redraw these boundary lines among disciplines. Before it is history, literature, data science is data science. But now we use a lot of skills from other disciplines to do humanities. For example, data science, geospatial analysis. This involves some data knowledge and some coding knowledge for create interactive maps. So actually it expands the scope of humanities, what you can do as a humanities research. And also, as you know, we humanities have these responsibilities to educate the public for to appreciate human values, to have this public spirit, critical thinking skills. So digital humanities really expands this audience and social impact of scholarship, because now you see public humanities projects everywhere. And a lot of places like museums, you can they reach out audience through digital means, such as these online 3D exhibitions. There are crowdsourcing projects that ask people to join and transcribe historical documents that AI reading doesn't do very well, because historical documents are usually very cursive writing that create difficulty for OCR and AI writing. And also it develops new forms of inquiry and knowledge production. Before, most humanities research focus on reading and writing. Now there are this fabulous variety of forms of scholarship. You can have video, audio, podcasting, for example. You can create a digital archive to benefit people around the world instead of having them only in school library. And also you can have, now is the AR and VR are very popular. You can put many things together. For example, those treasures of ancient Egypt, they are scattered around in the museums around the world for exhibition. But with 3D and VR technology, you can put them together in your project. So for the first time in the past thousands of years, they get together and you can see a full picture maybe of an Egyptian temple in your project. And also the project-based learning is a great benefit digital humanities brings to students and researchers, because it is collaborative and interdisciplinary. But also it's like a coin has two sides. There are also serious challenges to humanities scholars. So first is this digital literacy. As I said, digital humanities is a booming field. So in the past training of humanities, there were not many technical classes that teach you coding, doing digital projects, archiving, etc. So when we face so much technology now today, there is a gap between this technical training in humanities. So that's actually prevents many humanities scholars from stepping into the digital humanities fields, because they are not sure what will happen. The second challenge is the cost. So to have digital projects, it involves cost, not only financial cost, but also human resources. And on campus, we have support staff, but not many, but we still have. But once you leave this higher education environment, you might even have less support for your projects. So these are, and also another challenge of this is open scholarship. So now higher education advocates for open scholarship. You don't have to pay so much to read an article or to get access to a digital project. But because of the current law, it's like the cost actually on the producers. It used to be on the readers, right? Now it's up on you. It's not free yet. So it's just different people pay for it. So it's a challenge to have open access scholarship now in the library. But I know more and more universities now have funding to encourage faculty and researchers to have this open access scholarship. Another challenge is the current higher education system, like faculty, they are tenure track. So as digital humanities is a booming field, some people question that if it can be listed as your serious work, like a book. So there was a funny thing that a digital media professor, he did digital humanities projects that end up in a book, because people recognize book as your work, like a serious scholarship. That's actually a challenge for many faculty members to work on digital humanities projects, because it is time consuming, and in the end, they want to be taken seriously in their resume. So another another major challenge of digital humanities is this cost. So this is a quote from our Humanities Dean's letter on February 1, 2023. And you can see this stark imbalance between funding in STEM fields and digital humanities. I was very surprised to see it's much closer to 0%. For federal funding for humanities research than STEM, like science research. So we are really pinched by this financial support from various government. That's why we need to look inward. We look our own UC Tech resources. Actually, we have very rich technical resources for all research. It's just in the past, they were mostly used by STEM fields, but that doesn't mean they were built by beautiful STEM fields. So that's why Jeffrey and I are here to advocate this use of UC Tech resources for humanities fields. The common digital humanities methods usually include data visualization, mapping, text analysis, archiving, crowdsourcing, as I told you, for digital archives, and also transcription, OCR, audio like podcasting and video interviews, and web publishing. So you see these digital formats compared with STEM fields do not take so much digital storage space. So we do, it's nothing for the whole UC Tech infrastructure to hold these projects. However, there's a gap of knowledge between what we can do as IT staff and humanities researchers. First, it is IT staff. We are IT professionals, but most of IT staff don't know what humanities are mostly interested in. As I told you, digital humanities, if not many people know what digital humanities means, even if humanities researchers. So let alone IT professionals. They can solve technical problems, but as I showed here, there are some special interest in like data visualization, mapping, etc. On the other hand, humanities researchers, they don't know what IT resources the school has. They know we have this WordPress service. They know if they can open a Word document, or they need to seek help from us. But for this deep interdisciplinary digital humanities research, they don't know much about what UC can provide, but actually UC can provide a lot. So today we would like, Jeffrey and I would like to use this example called Nautilus. It is a research platform UC has, but our project is the first humanities project on that. There are hundreds of research projects on this wonderful platform that has fast computing, team collaboration, and global access, that you can have access to this platform anywhere from the world. But it was neglected. That's why we are here to present our projects. So as you see, like one out of 500 projects on this platform are for STEM. So it is easily misunderstood as a STEM research platform, but actually it's not. It's just a Python. It's a Python environment, and you can do everything for team collaboration and fast computing. So now, yeah, Jeffrey's turn to let you know this wonderful platform.
All right, well, thank you, Xiao. That was a very nice introduction to the problem space. I'm kind of a free range presenter, so challenge to the cameraman. This is sort of a recap of a talk that I gave last week at the Digital Humanities Conference in Graz, Austria. And it was fairly apparent to me that this was a very sophisticated crowd. I asked them how many people in the audience knew about Jupyter Notebook, and almost everyone raised their hands. So that, indicated to me that at least that community is aware of these things. But Ming Hui Hu and I, he's a professor in the history department, were the only two people from the UC system at this conference of over 500 or 600 people. So while I was out evangelizing these techniques and tools there, I need to come home and do that as well. So this is an interesting statistic that I came across, and Google Books now contains over 40 million books in more than 500 languages. So what is a humanist to do when everything is digital, and the stacks of parchments and books that they used to ensconce themselves in are now bits and bytes? It really is a matter of scale, right? So the central challenge is, do humanists continue to do what they have always done, or do they pivot and adopt some of these new computational methodologies? And I think that if they had the tools and the training, that they would absolutely move in this direction, just because there are things that they can do in this area that are not otherwise possible. So one of those things is the use of artificial intelligence. Now that is quite the buzzword these days, right? You have all kinds of things talking about AI, but they all sort of have these 4 basic ingredients that make them up. They're models, they're platforms, and we're going to talk a little bit about that today, the data, and the algorithms. Now, in some of these, the humanists are doing very well. They have great data. They're very good at data. But in other areas, platforms, models, and algorithms, they may be struggling. Now, there are 6 broad categories of AI: reasoning and problem solving, knowledge representation, machine learning, natural language processing, perception, social intelligence, and general intelligence. This is the one that general intelligence is what we're really kind of encountering more and more often. And when you use something like ChatGPT, what you're really doing is tapping into almost all of these other areas of AI that are sort of packaged together and then abstracted by a user interface. One of the things that we're particularly interested in giving humanists access to are these large language models. And I didn't come up with this definition. A large language model came up with this definition, but it's pretty good. It's a computational system designed to understand and generate human language. And it turns out, so are humanists. They are designed to understand and generate human language. So it's our supposition that humanists and large language models should get along like gangbusters. And it turns out that as these language models get bigger and bigger and bigger, they exhibit things called emergent behaviors. Now, I heard this story might be apocryphal, and I'm still looking for more of a formal reference for this. But in a seminar that we had over the spring on generative AI, we were talking about prompt engineering, which is a way for you to refine your generative model to do it something very specific to your domain. And someone mentioned that they had heard that a large language model like ChatGPT had been exposed to a language that it was not trained against, given a question and an answer in that language, and repeating that process dozens or maybe hundreds of times. All of a sudden, the language model itself understood the language and was able to respond not only in this language, I believe it was Khmer, but also in this script, which is not something it had supposedly been trained against. So it may be that these large language models are a key to unlocking new knowledge for humanists. Imagine if you had a corpus of, let's say, 20 million characters or words from classical Chinese texts, and you wanted to ask a large language model about, let's say, food, ginseng, and the importance of ginseng. If you took a traditional approach, you would probably have to go through a very tiny fraction of those things, maybe doing keyword searches, maybe looking around in the adjacency of those words. But if you trained a large language model to look at that corpus and answer the question, it might give you a very surprising answer. Now, of course, it might just lie, and you wouldn't really be able to tell. So we're not going to turn over the keys to the kingdom to these systems, but we think that we might be able to develop ways for humanists to use these systems in new and interesting ways. But like Xiao said, there are significant challenges here. There's, just access to these computational platforms. There's a lack of programming skills. They may be experts in their own data, but they may not be well-schooled in data science techniques, which are adjacent to the data. And of course, just in general computational techniques. So let's address one of those shortfalls first, the platform. Any gamers in the room? No, maybe a little bit. Anybody had to buy a GPU recently? You can spend thousands and thousands of dollars on these GPUs. And to do machine learning, you need to have more than one. And one thing that we do know is humanists don't have just piles of money laying around. But it turns out that people in the STEM fields kind of do. So the first platform I want to talk about is just campus HPC. This is high performance computing. This is the traditional supercomputer that you've heard about. And HPC in the UC resides in these places, either in a core facility, a center, an institute, or in about on 3 campuses, no designation at all. But it is a service that's developed. It turns out that I run HPC on the UC campus with a small team of dedicated staff and volunteers, and anyone can use this platform. At UC Santa Cruz, you don't even need a sponsor. All you need is a UCSC email address. So if you're a humanist out there and you're wondering how to access parallel computing, hyperscale parallel computing, your HPC center is the first place for you to go. But those HPC centers weren't really meeting the demand. They weren't really able to provide the number and level of GPUs that researchers seem to need. So about 4 or 5 years ago, Tom DeFonte and Larry Smarr from UC San Diego, Larry is the just retired former director of the Qualcomm Institute there, did an analysis, and there was a gap between the GPUs that you might have in your lab or on your desktop and the GPUs that were being provided by the large scale cloud providers like Google, Amazon, and Microsoft. And in that gap, they built Nautilus. Nautilus is a hyper-converged cluster. It's distributed, meaning there's some stuff in Santa Cruz, there's some stuff in Santa Barbara, there's some stuff at, well, not here at Berkeley, but in many other campuses. And it's multi-institutional. And all you really need, again, is that email address to your home institution. With CI Logon, it's a federated identity management scheme. And the basic principle is if your institution trusts you, we trust you. It runs on Kubernetes, and whether you recognize that word or not, it's an ancient Greek word that means navigator. Kubernetes is the technology that runs the internet. When you open up a web browser and you go to Google search, you're not interfacing with a Google web server, you're interfacing with a Google Kubernetes container. And it's your own personal instance. And just like that, Nautilus uses these own personal instances of computing to give you godlike powers over the platform. Nautilus is distributed. So this sort of central cloud, I don't expect anybody to be able to read this, is all of the US-based stuff, but we have stuff in Oceania, Asia, and in Europe. They're all connected by high-speed network. And on this system, you load up your data and the computation goes to the data. The data does not move to the computation. It's also very large. Now, today it has 1,228 GPUs. 1,228 GPUs are in Nautilus. That's enormous. And they're of all different kinds, from sort of very basic all the way up to the most expensive, most complex cards available. If CPU is your thing, just a general computer processor, it has almost 20,000 cores. That's an extraordinary amount. And attached to the GPUs and the cores is 95.45 terabytes of installed RAM. And there's also in Nautilus almost 3 petabytes of spinning disk. So it's quite large. It's also a community project. If you want access to Nautilus, you log in, you're a guest, you go to Nautilus, the chat channel, and you get promoted to user or admin. If you have a question about it, you ask the community. And in that way, we sort of spread out the IT workload to the broader community. And we do peer and near peer mentoring and build this community of practice. So I put this QR code up here. If you want access to Nautilus, you can follow this to the portal. I won't go through all these steps, but there's basically 3 steps. The first one is you have to configure your local system because that's how you interface with this. You don't log on and get a web browser interface like Netflix. You actually have to configure your system and use a Linux command terminal, which is a little bit of a barrier, and we might talk about that. There's 3 levels of access: guest, user, and admin. Anyone can be promoted to admin, especially if you're in the UC, that's not a problem. And then there's a set of tutorials and help documents that are required before you get started. One of the really important things that we run on Nautilus is a Jupyter Hub. And a Jupyter Hub is a way for you to run Jupyter Notebooks. Jupyter Notebooks, how many, everybody know about Jupyter Notebooks? Yeah, Larry Smarr called them the most important invention since the web browser. And that's an interesting statement from Larry because he was director of the National Center for Supercomputing Applications when he told Mark Andreessen to go out and make a web browser. So they invented Mosaic, which became Netscape. Jupyter Notebooks are a way for you to mash up your code, your documentation, your visualization, and they're highly portable. And we use them all the time on Nautilus. If you have a project, you might consider standing up a Jupyter Hub. A Jupyter Hub lets you have sort of a custom kernel and a software stack so that your researchers don't have to worry about those kinds of configurations. It's customizable, flexible, scalable, and of course, portable. And I am a fierce advocate for this technology. And then the last sort of collaboration tool that we like to give to our researchers is a code repository. And at UC Santa Cruz, we have GitLab. Other institutions may have other versions, but the idea is that you can place your code up, you can make it public or private, and you can share the code. Others can grab a version of the code, make improvements to the code, or suggest them to the main branch. And it's a way for, it's a centralized location for developers that can store, manage, and collaborate. Now, I would imagine at UC Tech, many of you say, yes, 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 code repos, that's how we work, that's how we work. But this is kind of a new concept to humanists, and it's a slide that I always want to put in there for them. I think with this project about the classical Chinese text, we're not going to be sharing data. We're only going to be sharing code and results. And that sort of gets us out of this very sticky business of intellectual property and signing MOUs and trying to get everybody agree not to share this part of the data or that part of the data. But I think if we can just get the code and the algorithms and the results shared, we'll actually do quite a bit of progress. So Nautilus uses namespaces. You can think of that as user groups, and to provide access control to data. So if I have my data and Zhao is in my namespace, but Angela and Mary are not going to see my data. I am not going to see their data. And while we don't host anything that's sensitive or private on Nautilus, this is an assurance that we can give people that their data are protected and are not exposed to the world. In this Chinese classical Chinese project, we expect to use a subset of the data to sort of develop the algorithms and tune our approaches and do this prompt engineering that I talked about. And once refined, we can share that model back to the data owners, and they can run it themselves and share their results. So we have basically 3 hurdles that we're addressing here. The first one is platform. The second one is collaboration. And I don't have a slide for the third one, but it is developing competencies in these computational methods. So in the last session, we heard someone from UCSF talk about the carpentries, and we intend to develop a specific carpentries track for humanists so that they can start to use those other techniques and unlock some of the things that the STEM people sort of take for granted. Zhao and I are both certified instructors, and we're going to start with the basics. We're going to teach people how to use the command line, because without the command line, they're not going to be able to access Nautilus, and they won't be able to access other HPC resources. So we're really going back to first principles. And I would much rather train somebody in computational methodology than train them to be a humanist. You know, people work their whole life to be experts in that domain. I can teach you how to use Nautilus in an afternoon. So I think we have plenty of time for questions, do we not? Okay, great. So if there's anyone in the audience in this vast group of people here, you know, I'm going to run the microphone, and Zhao will take questions. Did we get any from the audience, Dave? All right. Yes, sir.
So I'm at UC Davis, and I support our College of Letters and Science. So that includes humanities and social sciences and STEM fields. And it seems like they're all kind of on this curve, but the humanists are way over here and the social scientists are way over here, and the STEM people are on the other side of the curve already for the most part. And even with the social scientists, it's a hard problem to get them, when they have been used to running software on their own computer in an isolated environment, getting them over that activation energy to get into HPC is really tricky. So I really appreciate the approach that you're taking. I'd be really curious to know what other types of topics you think go into these carpentries that would be accessible to humanists specifically, like beyond just the command line? It seems like there's just so the list would be so long as to be daunting.
Yeah, so I think the strategy for success there is for us to build a corpus of really good, solid examples in Jupyter notebooks that people can take a hold of and use themselves. But more broadly, I think to answer your fundamental question, which is how do we get people to adopt these shared platforms and these scalable and sustainable approaches, is we just have to build world-class systems. We have to make something better than anything that they could possibly do on their own, and then invite them in and be welcoming to them. So I was delighted yesterday when I got an email from one of our faculty researchers saying, we would like to use your system for our research. How do I do that? And that got an instant reply from me. So I think a rich set of examples that speak to the people who are, that have these challenges. So I can imagine, although we have no concrete plans, that we would do a carpentry style workshop block for data visualization, for large language models for humanists, R coding, Python coding, something as gnarly as just data cleaning, showing people how to use Python techniques to clean their data and make it ready for downstream use in something like a large language model, I think would be really helpful. I don't know, we're just starting on the journey. Yes, sir.
Go ahead. I would like to add some points that for Python training, so many disciplines use Python. So it's kind of hard for us, like if we hold a carpentries, it is kind of general because, humanities, social sciences and STEMs, they have different concerns. And I had this background training in Python and data science, but it's like a new language to me if I look at medical Python or other Pythons. So, but I feel the training for humanities, we can aim that they can read, they know the basic rules, they can read the Python. I mean, they can read this script, that what it means. You don't have to write it by yourself. I would really like to recommend GPT code interpreter. It's really like a data scientist at your fingertip. Because now it used to be like we upload the spreadsheet, use Python to analyze the data, and then do data visualization. But now that GPT code interpreter, you just throw in your spreadsheet and it does the rest for you. It's a Python environment and it has more than 300 libraries. Now we need to import one library after another, but it's just have 300 libraries there. So I feel it's easier and easier for humanists to have this, to understand Python and use digital technologies to research. Yes, you go ahead.
Yes, just a quick question. I enjoyed the presentation. I direct the School of History and Philosophy at Illinois University, and we've recently created a digital humanities lab. The only people that seem interested in it are the graduate students, and those, and exactly. And I'm not convinced my older faculty are going to go there. Although, as you noted, there's a problem for the graduate students when they become junior professors because they still need to produce a book in both history and philosophy. So I've been able to get job opportunities as GAs for them in the digital humanities labs, and they pretty much self-educate with some assistance from the coordinator. That only gets so far. Zhao, you mentioned that UCLA has a minor.
Yes.
Are there graduate certificate programs that I can recommend to our graduate students?
Yes, there are actually, it really depends on your specialty. For example, you use data a lot. I know Washington University in St. Louis, they have a humanities and data science certificate for graduate student and a digital humanities minor for undergraduate students. As I said, Python is a general language. So if you research medicine, you have your own way to write Python. So it's hard to find a Python journalist to teach you everything. That's why I think our carpentries for different people should have different lesson plans.
Yeah, and the carpentries framework certainly allows for that. I like the idea of having a certificate program. Maybe it could be hosted out of UC Extension. That's a very attractive way for us to make broader impacts into the community. But it's definitely something that I don't observe emerging yet. And I think it's one of the root causes why you see most of the people who are seeking that undergraduate specialization minor in digital humanities coming from other disciplines.
This question is in the chat from Lucas Clark. He says, how does Nautilus manage allocation of computing resources?
Good question. That's a very computer science question. It doesn't. If there are 500 GPUs available and you request 500 GPUs, you will get them. And in fact, unused cycles in Nautilus are scavenged by something called the Open Science Grid, which is a high throughput computing federation that has historically just used traditional HPC techniques, but now is refocusing on a lot of GPU and non-von Neumann architectures. And we always see a bunch of little slices of the pie and then one big slice of the pie, and that's always Open Science Grid. And for a while there, it was people detecting neutrinos in an ice cube project down in Antarctica. They had sensors a mile below the ice, and they needed to analyze millions and millions of images that they were bringing up from these sensors. So they were consuming all of the available resources that weren't requested. But if the person who posed this question went on to Nautilus and requested 100 GPUs, they would kick the Open Science Grid people off because those are, low priority, and they would have those resources themselves. Now, it's always a balancing act in these community shared platforms. If you request more than you are using or more than you really need, you're going to get the attention of the systems administrators, and they're going to ask politely for you to not do that once. And the second time, it'll probably be bye-bye. So like other community resources, it's kind of policed by the community, and everyone kind of keeps their thumb on this heartbeat of the system. Reporting in Nautilus is handled by Prometheus on all of the clients, and then that data are those data are rolled up into a Grafana report. And if you go and you search the Google terms Grafana, Nautilus, UCSD, you'll come up with that dashboard. So when people are encountering Nautilus for the first time and they want to scale up their research, I always encourage them to take a look at that page and see what resources are available and target their work towards those resources so you can grab them and use them. We do have a time limit on Nautilus. It's 2 weeks. If you have anything that's running longer than 2 weeks, you're probably not a good use case for Nautilus. And in that case, there's an excellent program at Purdue, and we can get you over on their GPU platform, which does support very long running jobs. Any other questions from the audience? So let me just put in one plug. if you go to Nautilus today and you try to navigate this onboarding and tutorials, it's a little painful, I have to admit. And it is almost painful by design. You can imagine having 1,200 plus GPUs might be really attractive to people doing things like Bitcoin mining or password cracking. So in order for you to get access to Nautilus, you will need to interface with a human. And that human is quite often a Russian engineer. His name is Dima, and he's a pretty good gatekeeper. So Dima also wrote the documentation, and it's very much from an engineering perspective. And as it turns out, my research focuses on using generative AI to make improvements to technical documentation. And I am presenting a paper next week at a conference called Practice and Experience for Research Computing, PERC. And in there, I will be highlighting some, let's say, shortcomings of the current documentation suite. And the next phase is a human-centered redesign of that documentation to make it, let's say, to improve the learning outcomes for the training audience. So stay tuned. So if you're going to access Nautilus now, I apologize in advance. We're working on it.
Do you have other questions? I think our time is up. So thank you for attending our session.
Thanks for organizing.
No problem. Yeah, I'll see you somewhere in the future.